playing Yu-Gi-Oh!
Right, I set you some homework.
Yeah.
Find your average walking pace. Well, maybe not average because you weren't doing that for the whole excuse me, week. So, do we have some offers on what you managed to get?
Very late with Vanguard games.
Oh, were you really? Come on.
Horse, taught by some old guy.
You work. Isaac doesn't have a phone to play on.
Yeah. Unless I can play Bounce somehow on my phone.
Guys, you just walked in late.
Yeah. Well, we left the 12:30 for the other day.
So this clock is 2 minutes.
Bartek, you belong in the morning.
Where?
Morons.
Where?
Look at the shirt and you'll know.
Oh, the universe is made of more.
Morons.
Protons, neutrons, electrons, morons. I belong in the electrons because I'm always very negative.
And a moron too.
And that means morons are technically the electrons.
No, it's my comments on Donald Trump's alternative science, things like that. Because anybody who comes out with some of the views about global warming, he cannot be made of normal.
Where do you get these shirts? I need to
I
order.
know, clickbait on Facebook, it's bad, it's really bad. Look out.
Make a paint on anything.
Yeah,
Clickbait.
right, so, do we have any offers then on what your average walking pace was? Yeah.
5.3 kilometers.
Okay, how did you do it?
Well, I divide distance by time.
Yeah.
Do I like say what?
Yeah, well, how did you measure your distance?
Well, I mean, I had my phone and I had my navigator. I needed to buy some groceries anyways, so I decided to walk a while to Prisma, near my house somewhere, and then and then I also had like a stopwatch,
Yeah.
and then I stopped. At,
Which
like,
navigator did you use? Google Maps?
I don't think Google.
Okay, but that told you the distance.
Yeah, it told me the distance anyways.
Okay.
So I got like 1.6 kilometers from my house to Prisma.
Yeah.
And then it took 0.3 hours.
Okay, good. Who else did it using like a navigator like Google Maps and a stopwatch? No one. You did, Kate. Yeah, what did you get?
I actually don't know how to calculate. It got 73.8 like meters per second.
3.8 meters per second. Okay,
73. I think there's something wrong with.
that's fast.
I don't know.
Very, very fast. 3.8 meters per second. How do you convert it to kilometers per hour? What's the quick way of doing it, Karthik?
Isn't it like multiplying by 36?
Times it by 3.6.
Oh yeah, 3.6.
Yeah, which was going to come up with
Over 10 kilometers.
yeah,
Pretty
over
fast
10
for
kilometers
walking
an hour.
pace.
That's very, very fast. Okay.
Oh.
And I don't think my results are reliable.
No, I don't think they are. That's okay. That's all right. So, what other methods did you use then?
Well, I already knew the distance from home to school. It's 1.5 kilometers, like roughly,
Yeah.
completely exact. And then I just took time with it because it didn't. So it's around 6 kilometers now.
Yeah. Okay. So, have you measured that 1.5 or?
Yeah, I've measured it at
Yeah.
some point.
Okay. How many else have you used a known measured distance and then just timed it? Yeah. Okay. Anybody do anything different? Okay. What values did you get then? What did you get?
Well, I walked. It was 1.2 kilometers, and I walked it in 8 minutes.
So tell me the speed.
I forgot to calculate it.
Fool.
I am a. I know.
Perfect, put your hand down, give everybody else a chance. Anybody else? Anybody more than 5.3? Yeah. 6.4, fast walker. Did anybody use an app that directly told them what their walking pace was, like Runkeeper or Strava or something like that?
So like, do you mean that?
Didn't even bother.
Yeah, you just
So-
put it
so-
on, you
so-
walk around, and then it tells you how fast you went.
Didn't even bother.
Yeah, they do. Okay, right. Okay. That is fast. 5.3 is pretty usual. Somebody in the Monday group got 1.74. They were slow.
That is really
Oh,
slow.
no.
Yeah, I know.
That's like.
Okay, good. Right. So today we are going to. Are there any questions about that homework?
I think we stop moving the table. It was last.
No. Yes, Karthik.
It's like, cause like I've heard that like 6 kilometers per hour is like the average walking speed.
I don't think it is. I think slower than that is.
Like 5.8.
Why?
No, I'm just asking.
No, I think you 6 kilometers an hour is actually quite a fast walk.
I'm more of a biker myself. I don't like walking.
There's an everyone prefer biking.
But I don't think
Yeah.
biking.
Okay, so today we are going to learn about. Actually, we haven't gone through. Okay, hang on. Brain work. Right.
Brain not be able to use. Loading.
Changing velocity. Okay, and solving problems.
Yeah.
Okay, we've got to work.
Life is a problem. Well, then you have a problem.
Fairly fast because we have actually got a Wednesday where we don't have a lesson.
Really? Why?
We've got a theme week coming up in 2
Oh,
weeks.
That doesn't mean we end at 12:15.
It might do.
Might, maybe.
Right. Kate, how's your finish come along? It's okay, is it? Let's have a look.
Oh, yay. Forget your.
Can you understand that?
I can't say that top E word. That first thing meant example, I guess.
Yeah.
The one at the bottom means some picture, something related to picture.
Yeah, pretty good. Okay, it's good enough. Well done. Impressed. Very impressed. More than I learned in 6 months. Right. I am going to teach you a basic method for solving these sorts of problems.
Look at the graph.
No. Now, not everybody looks at that and says, oh, it's easy. Some people do. They can do it in their head really, really quickly. And this will be very obvious, and it does depend on your mathematical ability. But quite a lot of people hate the fact that physics is so mathematical.
I like that.
Mute. Okay, so how do we solve problems like this? This is straight out of ILMIA. This is ILMIA page 139, I think. And I'm deliberately choosing to have a problem in Finnish rather than English because you don't necessarily need language for the first part of this because it's solving them in Finnish or English is exactly the same. You're solving a physics problem. Okay? So what do you do when you are faced with a problem like this, with loads and loads and loads of words, and it might just as well be in Mongolian, some people think, because the first thing that you have to do, how to solve things like this, you can write these sorts of problems. You can write what I'm writing if you like. Well, it's a good idea to do so, actually. Okay. So how do you solve things like this? Well, the first stage is face your fear.
We can write this down.
Yes,
Okay.
because if you go into something saying, I'm scared of this, I can't do it, you won't be able to do it. So number one, face your fear.
Like when I started swimming.
You're muted.
Oh, yeah. Breathe in.
Number two, read and identify numbers. Okay, so you identify numbers first of all. Words, 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 words. I can see a number there. I can see a number there. I can see a number there. Okay. Number three, read and identify units. Meters, kilometers, seconds. Now there it's a bit irritating because it's written as a word, which if you don't speak a language you might not get, but
Well,
an intelligent person can say sekundissa is seconds, to do with seconds.
actually, it's minutes.
It is
No.
second.
It's a second.
Yeah.
Just kidding.
Yeah, I know. I just say this.
What, Karthik?
No, he's muted. Number four.
He just shut him down.
Oh, Karthik wants me to be muted.
Number four. Read and identify what you want to find. So actually, you've now read it 3 times. Why have I made you go through this horrible procedure of reading words? Because usually you don't bother reading anything. You look at the last question, last line of the question, and that's what you do. And it's not always correct. Every time I mark the tests, somebody's missed a question out because they haven't read the question fully or properly. So, go back to basics here. Right, what do we want to find? Now, we've actually got to translate this. So, the pictures show the journey of Oliver moving or walking in a straight line. Answer the following questions using the graph or the picture. Now, what do we want to find here? Millä aikavälillä Oliverin nopeus on suurin? What do we want to find? You're muted.
We want to find out at what point in time his speed was the highest.
What time? What time? Okay. At what time was his speed the highest? Now we haven't got any numbers here. So actually we've read the question and it's told us that we've got to look at the graph. So here are our numbers. Here are our units. When was he walking the fastest? Okay, Monica.
From 0 to 4 seconds.
Yeah, from 0 to 4 seconds. How do you know?
Because it's deeper there.
It's steeper. Yeah, it's steeper. Or you could say he's gone 8 meters in 4 seconds, so he's traveling at 2.5 meters per second. But here he only went in 2 seconds, 2 meters. So you could actually do it in numbers, but yeah. Okay. What about our next question? We've identified the part B. We've identified the numbers. We're now going to read it. What do we want to find? B. What do we want to find? Karthik, unmute.
The distance he's travelled in 3 seconds.
Yeah. So what specifically are we going to calculate?
It's like
What quantity? Is it a time, a distance, or a velocity?
distance.
Okay, back to mute. Okay, so we want a distance. So in these questions, we are fiddling around with distance. You don't have to write this, speed or velocity, and time. Yeah? You will always find 2 things and want the third. Yeah? You look confused. You have a frown. You're okay. Yeah. Now that method, we could go through all those questions on there. They're in the ILMIA book. But let's try an example.
Why did you make a line? On top of
It was an accident.
You said you have OCD or something.
Yeah.
It's okay. I'm a nightmare, or my notes are a nightmare for any students who have OCD, because they are random. I am the antidote to OCD. If only OCD was easy to get rid of.
If it was curable, Karen would be the cure. Or would have found
Certainly
out.
aversion therapy. Right. Let's use a little example from ILMIA. You can write this down, and I'm going to put it in Finnish because it's great practice for us people who can't speak it.
Yeah.
Karen
That
can't
was
speak anything.
extremely.
He's muted. Don't pick on him. He can't answer back.
Why can't you just shut him down?
I'm saving that for some of you.
Giving him some
Hey, you're
food.
muted.
Yeah, no, still. Huh. Wish I was that fast.
Oh, really?
Okay, yeah, you can write this down.
We can, but we don't have.
I don't have to make you do anything,
Shit.
but I can make you feel very, very bad if you don't do it.
I'm not the answer.
Nope. You are not the answer.
Kate, have you got any idea what this question is talking about?
I don't know whether it means how. I don't know long.
Good.
I don't know.
Very good though. Right, äänen nopeus, speed of sound.
In the water.
Any idea what Vedessa might be. In water is. How far does sound travel in 4.5 seconds? Right. Put your hands down.
Oh,
Some of you are going to tell me the answer.
I've never seen.
No. What do we do? Face your fear.
Find the
Read and
numbers.
identify the numbers. 1500 and 4.5. Now, it's a really good idea to actually write down the numbers as you identify them. It makes your brain work. Now, next we have the units. Meters per second. Per second. And most importantly, what do we want to find out? Yeah. We want to find a distance. How far has it travelled? So, now when you do your test, you might be using one of several formulas, which you're going to have to remember. So I can do a deal with you on that. You can remember them or choose to be given them and lose a mark.
Wait, what?
Okay?
Oh, it's great.
The test you've got to do will include some formulas. Yeah? Now you can choose to remember them, or I can give you the formula in the test and you can lose the mark that
What do
you
you
would
mean,
have got for
Lose
that
the
formula.
mark.
1 point goes down. You go down a point.
Like you mean like if you get an 8, then you get a 7.
No. If the question gives you 4 points,
Then you get
Oh,
3.
that way.
Then
you would get 3.
Okay.
Yeah? So that saves your memory. Yeah? Does that make sense?
Yeah.
Rather than not being able to do it at all.
Sounds reasonable.
Sounds pretty fair, yeah.
Okay. So you have learned, hopefully, a formula that connects meters per second, seconds, and distance. Speed, time, and distance. So you write it down. Or velocity or speed is distance divided by time. And I would expect you to write it down. I don't care what sort of divide sign you use. Yeah, provided it's clear, it's a division. So it could be 2 dots, it could be 2 dots with a line between, doesn't matter. Yeah.
Does it have to, do you actually have to write that velocity equals to this?
I will accept V equals D over T.
Do we have to like write?
Yeah.
Exactly. Like,
If you want to get 4 marks out of 4,
okay.
1 mark for the formula.
V equals DT.
Okay. So, what you then have to do is show you understand what a velocity is from that question. And the velocity's got the unit meters per second, and you put the velocity in the place where you wrote velocity, like on the right side of the equation. Yeah? Velocity, its distance, we don't know. Over time is 4.5.
What do you do, like, X?
VT equals D.
Or you could just.
Yeah, I don't mind how you work it out, but you do not just write down the
Oh,
answer.
is that another formula? The distance equals 15.
It's the same part.
Well,
It's the same formula.
It's
I've just taken that up
the
there.
double line thing
I've
and
just-
then
D
time.
equals VT.
I've just cross-multiplied.
It's like they're using the double line thing that Auntie keeps doing.
This is cross.
Oh, because there were what?
Alright, just do like two
How's it
lines and then
related?
time for, like 4.5. That's how Auntie always does it and we always understand.
But that is a mathematical.
No, it doesn't.
That wouldn't work.
It doesn't work.
Why not? It's
2
just-
lines and then times by 4.5.
Yeah,
Yeah, because or like we have to have the 1500 equals
It means like on
distance
both
being like
sides.
distance being d over 4.5. The double line means you add that to both sides, and if you add 4.5, it counteracts the divide by 4.5.
Is this a Finnish thing? Is it an auntie thing?
It's
I
an
think-
auntie thing.
I think it's a Finnish thing.
It works wonders for some people. It actually.
I get it without it.
Like if you're
Yeah.
calculating something like that,
I
then you have to do the line,
What kind of- it
do
helps.
that, and then next you do this.
I think it's a Finnish thing.
And then you have 4.5 times 1500 equals distance.
Yeah, I already got the answer.
Oh wow, I got
I
it.
will.
Okay, why do you write that?
I don't know.
We don't.
But it means that this is what you're going to do.
What's that supposed to mean?
Okay. Right, okay.
It's weird, I know.
It's logical.
Oh, well, that'll be another yard conversation with auntie then. What's your double line mean? Okay.
It
Well,
means
no,
that-
I don't care. If it works for you, it doesn't matter.
It means the said equation after the double lines gets added to both sides.
I think it means the operation that you're going to do next to it. Yeah. Okay. So, 1,500 times 4.5.
6,750.
6,750. In the usage flirted around.
Karthik.
Karthik.
I didn't do it.
We're not done.
You did it for second.
Meters, you wombats. It's a distance.
Wait, oh yeah.
Wombats.
Not a wombat.
And then bad little cough. Like,
Yeah, move the desk away from Karthik. Karthik, you're still muted.
Okay.
You're forced.
So, in a test,
I still don't get the fact about the 4.5. The arrow. I just did it on YouTube. Yeah. Yeah.
Karthik, just let me do it.
Really?
Oh yeah.
right,
Okay, so
let me try and explain it. 1,500 is some number
X.
divided by 4.5.
D divided by 4.
So what would that number be? How would you get that number?
how would I get that?
How would you work out what number the question mark means? Right, let's go back to an easier example.
No.
Shh.
You want me to explain?
No, 4 is some number divided by 2. What number, when you divide it by 2?
Or divide by 2.
What?
No, listen, the rest of you shut up, okay? Some number divided by 2
Uh-huh.
is equal to 4. What do you have to divide by 2 to get 4?
It's like x divided by 2 equals 4.
Well, what
X divided by 2.
X.
X over
Is
2
4.
equals 4.
So if you divide, what number is it that you divide by 2 to get 4?
I'm gonna use the double line theory.
Right? Are we like double line then?
You could.
No,
You could.
forget the double line. What number do you have to divide in half, divided by 2 to get 4?
I'm very bad.
This is where pressure really doesn't help you, does it? It makes you feel a fool. No. Okay, let's say that 4 and 2 are just having a bad day. Yeah.
They weren't going to.
So, some number that you have divided by 8 is 10.
Yeah, it's something divided by 8 is 10.
Yes.
It's the number that I used to wear at football, for heck's sake.
Wait.
It's 8. Oh my god, that's not 11.
Oh
Yeah,
yeah, wait.
Kate, go on.
Oh, easy.
Basically, like someone said just now, it's like basically 10 times 8.
Yeah.
Yes.
You can do
That's
the
how you-
lower number times the other.
Yes, yes, 80. Yes, it's 80, yeah?
Yeah.
Goodness.
Right. So,
Probably can
look,
confuse.
this may seem silly, but actually you get to a point where you've been doing more advanced stuff for longer, that this really, really gets confusing. So no.
So why is it?
Basically.
Now,
why is it
listen.
zero? Okay, yeah.
What is the connection between that number and that number to give you 80?
8 times 10.
Right. Whatever's on the bottom, you take it up there and you multiply it by
So
that
basically
number.
the double line. If we weren't on this lesson.
Yeah.
You can do the double line.
Maths
and
is
then
the
times
same.
it.
I don't care how you do it, provided you do it in your head.
Or on paper.
So if you didn't do the double line times 8, so we go to both sides.
What the fuck?
But
Yeah.
wouldn't the times 8 need to go
It will go.
on top of?
No, because
No,
it's already
because that's
divided by 8. The 8 and 8
Amar.
like crossed out,
Amar.
and then it goes like 10 times 8 is equal to X.
10 times 8 is equal. Yeah,
Yeah,
yeah.
we learned this last year.
Oh yeah, that's true. But where would you put
Amar.
the other times
Amar.
8?
Oh
Amar,
my
look.
god, I'm dying.
Amar.
I'm
Amar.
dying, kill me.
No.
Amar, let me show you. Amar, let me show you. Let me show you.
I'm getting confused because of
10
him.
times x over 8.
Mhm.
Double lines times 8
Yeah.
I'm getting so confused.
10 times 8
equals.
equals x over 8 times 8, like that.
Oh, yeah.
Those two counter.
Oh, yeah,
each
so
other.
that means 10
So
times 8
10
equals
times
X.
8
So
equals
8
x.
equals
8 equals x.
Oh, yeah. X, yeah.
That is how simple it is.
Right.
That's
So do you now get why that's 6,750?
Yeah.
Good.
excellent.
Okay. If you were in a test doing that, okay, 1 mark for, actually let's not use green because we've used that already. 1 mark for writing down something that shows you know the physics.
So that's
If you've forgotten the formula, I'll give it to you. You don't get that mark. 1 mark for putting the numbers in the right place. Yeah. You then work it out whatever way you want to do it without a calculator. Yeah. And then 1 mark for the number, 1 mark for the correct unit. 4 marks.
Okay, yeah.
Okay.
And
Correct.
how many of these questions?
Yes, of course the correct unit's worth
Yeah,
a point.
yeah.
You dingbats told me it was as meters per second. Right? Why is that important? Look, what did we want to find? The whole point of the question, you want to find our distance, so it's in meters. Okay. Sadly, yes, but with words, and you have to
Oh my
translate the words.
You wish.
Okay, right.
numbers with that.
Yeah. That answer to help you answer the next question.
Yay.
If the speed of sound in air is 325, let's do 320 meters per second.
That
How,
is it actually 320 meters?
it's 330, but there's a reason for this. How much later is the sound heard through air? And it's the same sound.
The way you're able to hear just more in the water, but later in air.
So the scenario is that 6.75 kilometers away, there has been a loud noise.
explosion. Michael Bay.
Yeah. And you've heard it underwater 4.5 seconds later. But how much later would you hear it above the air? Work it out. Put your hand down. Now, the first question we did, I'd expect everybody to be able to do in a test. This next question, getting it right, is much, much more difficult. Number one, face your fear. Number two, identify the numbers.
Yes.
Okay, that technique, it does work.
What decimal do I have to know?
Do it to one decimal place.
I think I got this.
Hold on. Oh, wait. And it's in the same distance away, right?
It's the same sound. Right? I always thought sound was faster in air than in water.
Yeah, me too.
And it's really fast in solids.
How fast would it then be in like metals, like steel or iron?
People used to be able to tell when trains would come by listening to the trains.
Yes.
Well, you can. You still can pretty much.
But it's advised not to.
Yeah.
I've done it just for the heck of it.
What? That's not a good idea. What?
Listen to the tracks to see if the train's coming or not.
Yeah. It's foolish, but you can do it.
What do you mean? Like,
If you could actually hear it through the tracks, the chances are that you can see the train. Or if you can hear it. If you put your head down on the track, because the sound travels much more efficiently through the metal and it travels quickly,
Yeah.
you can hear a train before you can see the train from where the horizon is. But if you can hear that the tracks have got a sound coming from them,
Yeah, then it's
then
fairly
the
close.
chances are you can see the train in the distance if
And then you'll
it's on a
die.
straight line. Well, then
No,
you move away.
or not.
I had a situation in like 3rd and 4th grade where I was taking a bus to my basketball practice, and it's like I didn't want to walk an extra distance, so I just always ran over the train tracks.
You run over the train
Yeah.
tracks rather than along the train tracks.
Not along, yeah, but over.
Yeah.
Yeah, but you can probably see the train.
It's probably
There was a train that
about
came 5 minutes
2 or
before
3
I was-
times as fast as it is in water. The speed of sound in a metal.
2 or 3 times faster.
Yeah, because
Than it
it's
is
more
in water.
solid.
Yeah.
More.
4,500
Yeah,
meters
it's
a second.
fast. It's fast.
That's like 2 seconds.
like
Less than 2.5 seconds in a solid would come from here to my house.
You sure about that? You live like 10 kilometers away.
9.9.
Okay, so we know 320 meters per second is the speed or the velocity. We know the distance, because we've already calculated that, is 6,750. And we want the time now. We write down our formula. Velocity is distance divided by time. And we've got 320 is 6,750 over time. I don't mind how you work this one out in your head, but, whoops, that's wrong.
Following the number.
The calculation you end up doing is this.
Yes.
Yeah. Which is 20 what?
It's about 21.1.
21.15.
20.09 continuing on.
21.15.
21 point what?
I was 29.09 for me.
I got 21.15.
Yeah, I go for 21.1. I think it's 21.09. 21.1 seconds. Yeah?
Yep.
Now, I wouldn't give you anything quite so mean in a test
Not
as
that
that maths.
difficult.
It wasn't that bad, no.
That
Pretty
bad.
But that's not the answer.
Yeah. Wait, that's not the answer to the question.
No, it's not. So the sound is heard how much later? 21.1 minus 4.5
Oh.
seconds later,
So
which
later.
is
16.6.
16.6 seconds.
I agree. Later.
Okay. But if you got 21.1, you get some of those marks. Now, why am I being mean and you not allowed to use a calculator?
Because we know how to do long division and multiplication using the squares on our notebooks.
Yeah. It's easy. I don't get why it's so
Right, because your maths muscle in your brain is a muscle and it gets easier to use with practice.
Yeah.
And secondly, the IB entrance test doesn't let you use a calculator. And a lot of you will want to do the IB entrance test. And last year, everybody said, it would have been easy if we'd have had a calculator. So it kind of freaked them out a bit. So I'm trying to build your confidence. Yes, Karthik.
One of the ninth graders that I was like, I was doing like a test during lecture okay?
Yeah.
And he was apparently doing his IB entrance test at that time. Or then he was doing some test and he said that is there going to be anything easier in IB than 1 + 1 + 1?
1 + 1 + 1.
Yeah. I think it's
What's the answer?
What? 3. Mathematical equation. Well, okay, it's 2 + 1 because you get 3.
Or it's 1 + 2, which is also equal to 3.
Depends what number base you're using, actually.
That's
Depends if
it.
you're using decimal. Right, okay, time for a 3-minute move your body stretch break.
And not your move my thumbs, Mer.
Yeah, and except if you play rock, paper, scissors.
I would use the formula.
Yeah.
I don't think I don't even know how fast. Like, I can't picture whether something is very slow or very fast.
No, that's okay. That's fine. That's okay. Right. So, 12. Shall we take the average and just say that is 12 minutes? Yeah. So 12 minutes. You have to change it either to seconds or hours, depending on whether you want it in meters per second
Oh,
or kilometers per hour. You've got that in meters, so let's make it into meters per second. So that's 12 times 60 seconds, yeah? Which is, am I right in thinking that that is 720 seconds? Yeah? So then your speed is 500 times 720. Yeah, and then for kilometers per hour, you times it by 3.6. So you times that number by 3.6. Okay, no problem.
Why is it 3.6?
Because you have to multiply it by 3,600 because there are 3,600 seconds in an hour, and then divide it by 1,000 because there are 1,000 meters in a kilometer. That's why.
Just lock the door.
Don't tempt me, but there are some quiet people out there still.
Really?
Yes. Quiet people who don't demand all the attention. Right, go on then. Hello. Not bad. You?
The guy sounded like Alan Walker. I think he's Norwegian.
You have to move this away from carpet.
Otherwise, I'll be using.
Confiscation. I paid 1,000 life points. Did this happen to be yours?
Wow.
Right, so next we will talk about how velocity changes. And yeah, we talk about acceleration.
Is deceleration a real word?
Yes, it is.
Is it
Yeah.
real physics?
Okay, so acceleration. And in Finnish, yeah, which is really
Similar.
tricky to spell. Okay, so when an object, a little bit of notes, when an object speeds up, it accelerates.
It slows down and decelerates.
Yeah. Yeah, it will do. Deceleration.
You wrote key to do on.
Oh, there's a Y missing, isn't there? Sorry.
There's a V that looks like a Y. There's a Y that looks like a V. And there's supposed
Is that
to be,
better?
No, because there's no two V's. There's supposed to be two Y's.
This one's great.
I wonder how many years it will be before Finnish doesn't reduce me to tears.
Maybe few so.
One more Y between the Y and the.
Sake.
Well, if you know how to write, why don't you just write?
Now it's good.
Because I don't. That one, I don't think I'll ever be able to learn that. How do you learn it? How do you know how to write it?
I have no idea.
Whenever I
Quite
go
a
to
guess.
finish this, I just guess.
Part of the problem is I can't hear the difference between one Y and two Ys. That's the
Voice
problem.
is hoarse.
Right. Deceleration is a decrease in velocity. Okay, there isn't a separate word for slowing down in Finnish.
He asked me then.
Yeah, he'd asked me then, but that means slowing down. There isn't a special word for deceleration. Okay. Now, when we talk about acceleration in everyday language, we tend not to be very scientific about it for the reason you are about to see. Let's see if we can work out what acceleration is. Well, acceleration, you need something speeding up or slowing down. It's the same formula. And if it accelerates quickly, it does it in a short period of time. The first example of thinking about acceleration is when you are looking at a car or a moped, and it's the time to get away from rest, like from traffic lights.
Right.
So, if you have a big acceleration, it means that you are speeding up very quickly. So a moped and a car sat at the traffic lights, the moped has the biggest acceleration first of all. So the moped will probably go from 0 to 20 kilometers per hour quicker than a car will.
Because it's like.
Because it's so light.
Yeah.
But very quick. You look at the traffic lights. If you're next to a moped, the moped can pull away faster. But the car will keep on accelerating. The moped can't.
Unless.
That's maximum.
Yeah. So, what is acceleration? We have another equation. Sorry about this.
Acceleration equals.
Acceleration is equal to the change in velocity divided by the time taken. So if it takes a very small time, you get a large acceleration. And that's important because you have to learn it.
Is it okay if we put like if we
CIV
if we
over
put it
TT.
like A is equal to
Not yet. You wait.
CIV?
No, because there is a specific code we use for it. Now, someone actually on the roof.
Really? I want to see.
Where?
I don't think it is. All right, sit down.
It's once in a lifetime.
No, they're not jumping off. It was just snow falling off the roof.
Not if you're a Nokia.
That's
And it isn't a person. Leave my gecko alone.
I have one of those.
Oh, right, now you can't. You've destroyed its feet sticker sucker thingies.
It's okay.
Can't you hear him scream?
No.
She's gonna give you a corner right now.
Right. We write that as A equals delta V over delta T.
Oh.
And you know your deltas, don't you?
We've learned it before, but I don't remember what
It means the change in.
Okay. Oh,
Wait,
yeah.
isn't time? Oh yeah, change. Time. But wait, is change? Is it? Oh yeah, yeah, there it is.
Alright. There's a game I've been playing on the computer called Kerbal Space Program.
Oh my god!
Yeah.
It's rocket science.
Yeah.
And from that, I've learned some of these.
Good.
With the Delta V's. Been practicing how to launch my rockets and
I'm gonna
Good.
play some video games now.
Now,
He said, well, how do you want me to
the units, what they're measured in. This is why we don't talk about acceleration a lot in everyday life. What is the unit of velocity?
Distance. Meters per second.
Meters per second. Our cyclist goes at a certain number of meters per second. You walk at a certain number of meters per second.
So it's not.
Time is in seconds.
So it's not kilometers per hour, or
It could be kilometers per hour, but Nobody talks about acceleration in kilometers per hour.
Okay.
Now, the unit of acceleration
Meters per second over second.
is the meters per second squared.
Huh.
What is this?
Meters per second squared.
Why did we say
Why?
I made a mistake? He knows it.
Because you are dividing meters per second by time. So you are looking at meters per second
Because they're second.
per second.
Yeah.
So it's second squared. You don't have to understand why. Just learn it. Just know it.
So when there's 2 units the same, I just put the 2.
Yeah.
Hey, what if it was like meters per second divided by meters?
Oh,
It would end up being per second.
That's pretty fast. That's pretty damn
Not like
fast.
m to the power of 2?
Meters per second
Yeah.
divided by meters
But, yeah, there's 2
Is-
m.
M S cancels.
Yeah, I guess.
Seriously, they do. Okay, let's see if we can put this into action
But why don't the s and the s get cancelled?
because they're both on the bottom. MS S. This is meters divided by seconds, yeah? It's meters divided by seconds, but it's also divided by second here. So it's M over S2.
I'm gonna just die.
But like, because there's a line, there's meters per second, and then under there's only one s the second. How does
Yeah,
S
but
go
the
down?
way that meters per second is the same as meters per second. That's just another way of writing divide.
I'm just dying.
I'm afraid you just have to accept it. You'll get it round about second year of high school.
Aw,
Oh, I got it already now.
we already. Sorry.
A hare
Oh,
is running at 4 meters per second. That's a very fast hare.
It is a fast hair. That's
And
that's 240.
sees
my hair can run.
the end of the race
No, we're not done again.
after 3 seconds. His speed is 6 meters per second. What is the hare's acceleration? Put your hand down.
No, I was gonna use the steps and everything.
No, just wait. Half the people in the class haven't written down the question yet.
Oh.
Give them a chance to think. Okay, what do we want to find?
Acceleration.
Acceleration. Hopefully, we have remembered a formula with acceleration in, which we write down. We've just done it. Within a test, hopefully you would know it. Hopefully, you've identified all the numbers. So, do we have enough information? Do we know the change in speed?
Yes. Change in velocity.
Yeah, I'll change in velocity. Yeah. So, our delta V is
Minus 4
6 minus 4.
over 3.
And our time is 3. So, it's 2 divided by 3. Did you all get that?
Yes.
Yeah, hopefully.
Meters.
0.67, I'm not finished yet, unit,
Meters per second squared.
meters per second squared. Okay.
But couldn't I just say meters? How am I gonna calculate 0.67?
It's about 0.67.
Uh,
Because 2 over 3 is an infinite number.
It's not national.
It's like Carthage.
How would,
Oh, no.
yeah, it's just the converting a fraction into a decimal.
does it always need to be to the power of 2 in the end when you're
When it's an acceleration, yes.
always?
Afraid so, yeah. This is why people don't talk about it that often, because it's a weird unit. It would be a question on a quiz show, what is the unit of acceleration? And most people would get it wrong,
That does
Yeah.
now.
because it's a bit too nerdy, quite hard to understand. Okay. Now, we do actually talk quite a lot about acceleration, but not using the word acceleration. We talk about, no, actually, let's not do that quite yet. Let's look at Mr. Usain Bolt's acceleration.
When is the test?
When is the test?
2, 3 weeks, wasn't
Usain Bolt had a diet of only
2
chicken
weeks?
nuggets.
it? Yeah.
Three.
In China, I think it was in China, like he went through around in the Olympics, and he didn't know any Chinese food, so he just had chicken nuggets, and he won. So,
Chicken McNuggets.
chicken. I think.
Okay,
Taryn, when was the test again?
10th of May.
I think it's the 10th of May.
Oh, 10th?
So like 3
There
weeks.
is time.
Play solitaire. What?
Karen gets bored in lessons.
That was before the lesson,
Play
10th of May.
Why not go play like chess or something, or online card games?
Or
Because
children's
my
cards.
brain can't cope with anything as intellectual as chess. Now,
That's all true.
if we look at this graph, here we've got Usain Bolt's velocity, and here we've got time. So, his speed is changing. This is actually really hard to do on a writing tablet.
MS Paint.
Yeah,
Okay.
paint is the best.
You couldn't draw that on MS Paint.
Yeah,
Wow.
much better.
What's in it? Paint.
Microsoft Paint. You don't
I
want.
don't like Microsoft. Just
Credit doesn't watch Grade A anyway.
Right. Starts at 0.
Yeah.
After about 1.8 seconds, he's going at 6
Karen,
meters per second. What?
to me, that looks like it would be 1.9.
8 actually. I would
It's
say.
2 there. Doesn't matter. Okay.
5.
It doesn't matter.
Actually, it does.
The ones you could do on your own, like.
kill me, please.
Don't. Right. So he's gone from 0 to 6 meters per second in 1.8 seconds. So his acceleration would be change in speed 6 over 1.8, which would be
Bit less than 4.
A bit more than 3.
3.7. 3.7.
3.7. Yeah, that'll do. Meters per second squared. He doesn't keep that up. That is probably his maximum acceleration because that's where the graph is steepest.
But how did he just go 6 meters per second in 1.8 seconds?
Because he's incredibly powerful. He kicks himself out of the blocks like that. It took those dots on there are every 10 meters of track. So they timed how long it take him to go 10 meters.
Oh yeah.
And from that, they then did the meters per second. Yeah.
I get the formula, but I don't know how am I supposed to calculate the division of this without calculating.
You do a thing called long division.
Yeah, but it's
I don't know how you've been taught
Math.
to do
Long division.
something like that.
oh, why you just do long division?
Yeah, 6 divided by 1.8 is the same as 60 divided by 18. Do you know that?
Yes.
Yeah? So I don't know how you have been taught to do that. I was taught at school to do that.
We were taught that too.
Yeah.
Yeah?
We learned that.
So-
Yeah.
I would get rid of the 1.8. So I'd turn it into 60 over 18. How many 18s in 60? I'd sit there with my fingers going,
4.
1, 2, 3.
No, 3, yeah.
yeah, there are 3 of them. 3 8s are
54.
48. Sorry, 3 8s are
54.
24,
54. Yeah. And then 3 1s. What am I doing? What am I?
24.
3 8s are 24. Yeah.
54.
Then add on
So
3.
that's like 6.
Yeah.
So it's like 3.3.
Are you following me?
No, it
Yeah?
wasn't 3.7. It was 3.3.
Yeah, it's 3.3.
Just gonna say that.
Mm-hmm.
That is correct though.
Okay. Now, in this sort of test, like in a physics test, I wouldn't get you totally hung up on bad long division. Okay.
Yeah, but I knew.
They might. They
You can
might.
worry about IB next
Yeah, but
year.
once you're practicing, you've got to practice, and it's easier with practice.
Practice makes perfect.
What is difficult is actually taking it out of the maths classroom over there and practicing it in a different room. That actually makes a difference. So doing maths in physics is actually doubly good for you. It's double good practice because you're applying it in a situation.
That you're probably never going to need.
Number, basically.
No.
Physics,
Now,
math. Physics, math.
so that is
Yeah,
probably the fastest human acceleration you can get. Yeah, that's really pretty fast. Usain Bolt out of the blocks
Biology.
is amazingly fast. However, we can all accelerate a little bit faster if we fall off a building.
Oh,
Yeah. Let's go do
9.8
that. Let's go
meters
try
per
this out.
second.
Now, the acceleration due to gravity.
But a human has the maximum velocity that it can
But it
fall
would
down.
depend if you go head first or like with legs first. Because head is heavier, so it goes up.
It's called G.
Yeah, I have a game where that's also, and it's not really logical because you can just pass out from hitting
Okay,
30 G.
9.8.
if you fall, you accelerate
Deceleration.
towards the center
Of the earth.
of the Earth at 9.8 meters per second
Hey,
squared.
that's like 2 times faster than.
Approximately 10 meters per second squared. We quite often round it up, it's so close.
What's the maximum velocity that a human can fall at?
There isn't one.
There is.
No.
Oh, you mean when they're falling through the atmosphere on
Yeah.
Earth?
Oh yeah.
Well, that's.
But like, there's a maximum speed that a human would.
Felix Baumgartner broke through the speed of sound.
Damn.
Was he one of those who
Who's
fell
he?
from space and then he was just falling and we?
Oh, the guy.
The guy who went up in a balloon,
Yeah.
and he took, what was it, 7 or 8 minutes to fall to Earth?
Is he the guy who started spinning and almost lost control?
Yeah.
Or is that different guy?
Yeah, he's the
He
guy.
was spinning a bit. But there's somebody else who's gone up higher and done it, but with less publicity since he did it. So,
I saw a documentary or something on TV.
yeah. Okay, now, you've heard of G-forces. We'll talk about G-forces next lesson. But what does this actually mean, acceleration due to gravity, 9.8 meters per second squared? Okay. Ignoring air,
What did that N mean?
about 9.
9.
Sorry, I'm being part Finnish. It's easier than writing approximately. And if I wrote that, it might upset some of
Just
you.
put A.
No, because A doesn't mean that.
Oh, it means acceleration.
Hmm. Or it means year,
Oh, really?
anno. Right, ignoring air. This means after falling for 1 second, your velocity is 9.8 meters per second. So, if you jump off Tietomar Tower
Yes. Let's do it. Into a floor.
and it takes you 1 second to fall, it doesn't. It's quicker actually.
Wait.
At the end of 1 second, you would be traveling at about 10 meters a second.
How tall is
As fast as Usain Bolt would be going.
How tall is the other one tower?
35 meters.
But then how do you get this down from there in less than a second?
Pretty sure it takes less than a second. It doesn't. No, it doesn't. No, it doesn't.
No,
Sorry.
it
Sorry,
doesn't.
sorry,
I
sorry.
jumped from 10 meters.
Yeah,
It
sorry.
takes, like,
It's like
Hey.
3.5.
It took like 3 seconds.
About.
About 3 seconds.
About 3.5.
Sure
Let's go
that
test
means-
this
2 and a bit. Sorry, 2 and a bit.
Can't come here, second.
Right, in your second, you go from 9.8. Well, let's do tens, yeah? First second, you end up falling at 10 meters per second. Your second, you end up
Second
falling
second.
at 20 meters per second.
Oh my god.
That's
That's
why.
Your
seconds.
third second,
Go from 20 to 30.
you end up falling at 30 meters.
And then you
Per
die
second.
and get swapped. And you squat.
Cumulative frequency.
Pretty much.
It's
Learn this-
cumulative, yeah.
Learn this in
Now,
math.
after 10 seconds, you are traveling at 100 meters per second.
That would be cool.
Not cool.
How would that not be
20
cool?
seconds, 200 meters per second. A minute, 600 meters per second.
Just a bit.
2 minutes, 1,200 meters.
1 minute, 20 seconds, you're traveling at a kilometer per second.
Minute and 20.
Minute and 20?
Minute and 40.
Yeah, sorry,
Minute
minute and 40. So acceleration means you are rapidly speeding up. And in fact, the acceleration due to gravity from our planet produces some very, very big accelerations on our body. Now, luckily, there's air resistance. So if you were falling from 11 kilometers up, well, actually,
Yeah, Karen, this is what I meant with like the reaching the maximum speed because of the because of drag.
yeah,
Slowing you.
Yeah.
Slowing you down to a point where you can't
Yeah.
accelerate anymore.
you will not actually accelerate all the way up to, the speed of light or anything
10,000.
like that, because
Oh.
air resistance is going to slow you down.
But if you could fall in space.
But what if there is no air resistance?
Yeah,
But
yeah,
then-
but,
but
if
then
there is
fall-
no if there is no atmosphere, then you've had it. So, for instance, landing on the moon where there's very, very little atmosphere, if you've got a rocket that is approaching it, or if you've got a spacecraft that is approaching it, it has to turn its engines off. It will then get caught by the gravity. It will approach slowly, and then it will speed up and up and up and up. And okay,
And that's
gravity on the moon is only a seventh of what it is on Earth, but it will still speed you up. So you've got to be very, very careful when you're landing on another planet.
And that is
No
why
atmosphere.
you turn your rocket ship around and start and start up your engine so that the engines will also slow you down.
And then you
Yes.
get out of the
Yeah,
Big
because you
with the
need to
little
land
curve.
safely. Yeah.
That's
So
one that
when,
you
for
find.
instance, meteorites impact on the moon and make their craters,
Yay.
they are traveling at hundreds of kilometers a
Yeah.
second.
Yay.
How
Not
about
100,000 though. That's
Yay.
how about the meteors that would fall on Earth? Wouldn't they be going?
Right, they are also going to be traveling at massive speeds. The air is going to slow them down a bit. So you get the bright flashes and the loud bangs and pressure waves, but they still will be impacting at maybe 2-3 kilometers per second.
Yeah.
And at that speed, when they impact, say they land on rock, okay, they actually melt the rock, they sink into the rock. The meteor may be absolutely tiny down here, but because of the heat that it's generated so very, very quickly, it makes a massive, massive
A
growth.
meteor the size of even less than a centimeter, having a diameter of less than a centimeter, hitting you on the head at enough speed will kill you.
Yes.
Is it possible to achieve light speed?
Not unless you are
Nature's so
light or electromagnetic radiation.
Is it possible for me to become electromagnetic radiation?
Yes.
Karen, as nothing is impossible.
You have to be completely annihilated.
But what if I have Star Wars logic and I can use a Millennium Falcon?
Then you are living on another planet of La La Land.
Oh, I
No,
love that.
not Star
Moonlight.
Wars.
Okay, so you jump out of an aeroplane.
Yes.
You've got a parachute with you,
Oh.
so that you will actually
Not that.
slow yourself down so that when you crash to Earth, you do not break any bones or something like that.
Or die.
Or die.
Or splash.
Yeah, or die.
Or become
Okay.
mush.
So, your velocity, your final velocity, is affected by the shape that you're going to be in. So, for instance, if you are falling and you put your arms out like that,
skydiving.
as opposed to diving like that, okay? If you are streamlined, you can actually have a
It's like you, so.
higher velocity.
Because you're breathing air.
Less drag.
Yeah, less drag. Here you'll have a lower velocity, but with a parachute, you actually end up with the smallest velocity
What
because
the
you've got the air catching in here.
heck? It's like before.
Okay, so that's increased
No,
air
the one of those.
friction.
Like the two that are going up are like the strings.
Oh,
Yeah.
So when you're skydiving, if you're in free fall and you want the highest speed of free fall, you do that.
But normally they do this.
And then your parachute fails, and then you're like, oh no.
And then you're what? And then
you
you're.
realize you're going to die.
Yeah.
Then you imagine you're James Bond.
Actually,
and
it's
just runs.
not.
Now, actually, everything falls at the same rate. Everything falls with the same acceleration,
Unless the
but it might not look like it because you can get affected by air resistance. And the usual way of demonstrating that is to take two identical pieces of
What about feathers? Do they go
paper,
feathers? Feathers.
They have
prove that it's a fair test, so they have the same mass. This has the same mass but a different
Yes.
surface area.
Destroy all the assessments.
Drop them at the same time.
the other one
Okay.
didn't even reach the floor.
If we took away the air, they would both fall at exactly the same rate. They would have the same G forces. Okay, and that experiment was suggested by Galileo,
With
the feather and the hammer being dropped. And Apollo 15 did this experiment. I know this is really, really bad quality,
I
but
wonder why.
think about it. It's about 50 years old.
Can't even see it.
And it's not even taken on or is it taken on?
It's taken over with the icon.
Is that taken on?
It's on the moon.
Beautiful picture,
Trump.
Hammer,
Dave.
feather.
In my right hand, a hammer. I guess one of the reasons
You
we
get to know
got here
the first
today was
video.
because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. And the feather happens to be
Why are you
appropriately
zooming
a
out?
falcon feather,
Make it more dramatic.
or a falcon. You know, drop the two of them here and hopefully they'll hit the ground at the same time. How about that?
I love that.
Or the
Mr.
they
Kelvin,
They
will
say,
correct in his findings.
They created an anti-gravity.
or what is possible is that they created an artificial vacuum, filmed it in the room, and
I don't think they did that.
I think that's not
Did they actually?
it's not.
It
But
is
it
possible.
technically it's
Okay,
impossible to
right.
get to the moon yet.
Not their time. They're not.
Get to the moon and come back alive.
All
Scratch it that
objects
I was born in something.
fall with the same acceleration.
But I highly doubt Galileo was in the law.
However, They may be slowed down
68.
However, they may be.
by air resistance, depending
On if you're in an
on surface area.
just call it drag. It's easy that way.
Yeah, but what makes drag? Surface area. Actually, velocity also
Yeah.
affects it.
Velocity over resistance.
I did this with my dad once.
You create an artificial vacuum, drop two items at the same time, have them.
Not with an artificial vacuum. I took an egg and a watermelon. Yes, a watermelon. So
Where did you drop them?
Somewhere.
On private space.
Must have been
It can't
messy.
Well, yeah, I don't have my messy, you know.
Oh, really?
Now you're Neymar.
But,
Have I teased you with the candle problem?
oh yes, you have.
Yeah.
Yes. Can we get another one of those problems? It was fun. We still have 4 minutes.
Okay.
Yes.
Or maybe we can go from the
No.
Yeah, that would be nice.
No, I want this problem.
I think you are the problem.
Thank you.
You have to, right.
I can't solve it out.
Okay, this isn't as factual. A man walks into a cave and he discovers a dead body. looks at the dead body, and the body's naked, and he says, "Oh wow, I've just found Adam."
Oh,
Do you
I
know it?
I know it.
I know.
Because
Okay, if you know it, don't say it. If you'll spoil it. Don't say it.
Don't even.
Adam.
Can I say it?
No, because it really upsets people who don't know it.
Yeah.
I kept your sister going on it for nearly not the whole of the journey to Tromsø, but
Yeah,
quite a
she
lot.
told me about like 11 hours.
Yeah, 13 hours in the coach, yeah.
13 hours thinking about it.
Yeah,
Eleven
no,
hours,
that's
sorry.
So, guy goes into a cave, finds a dead body, looks at him, says, "Oh, it's Adam!"
Oh, he had a friend
And he's
called
right.
Adam. He had a friend called Adam.
No.
No,
Friend called
Adam,
Adam.
Adam as in
Oh, Adam and Eve.
Adam and Eve.
Yeah.
How did he know it was Adam?
Exactly, that is the question.
Hey,
no.
Karen, can you
How
promise me
did
if
you know
no
it?
one can solve it, can I
No,
just
I wanna say it.
it? Do you know it too?
I know.
Do you know it?
No,
You know, yeah, because it was
Yeah.
your sisters were.
Are both our
Okay,
sisters?
me and you.
Yeah.
Adam.
You're allowed to